Hello and welcome again. I hope by now you would be feeling confident that we have been able to understand brain to some extent, especially with the networks which we have talked about, especially with the uh, structures which MRI and PET scan, and maybe the functionality and rhythm and oscillations which EEG has discovered for us. So broadly, you will not be wrong if you think you can grossly understand how the brain functions. But that is not the whole truth, because if you remember, when we were talking about MRI and PET, and there are a lot of exploration of brain which we do, apart from the post-mortem autopsy where we directly see the tissue. Lot of it is an indirect signal, and lot of it is task driven, in the sense that we give a task, a certain network or certain area of brain gets activated, then we change the task some other area. So this is not the full truth. Or if you take a EEG which may give you a signal from the whole brain, but then the EEG cannot tell you where is it coming from. So all the time we are struggling with this space or time differentiation. But when we are measuring, or even from the given data, if we are making network according to graph theory, still we are focusing on a very small low dimension part of it. What is the rest of the brain doing at that time? So is it like that a certain network gets activated in a task, and then you change the task, then some other network gets activated? Is there a switch in the brain which keeps doing all this? It's very, very unlikely. So the time scale problem, what are the other parts of brain doing when we are measuring a task dependent one type of activity or one type of network? Even theoretically, when we try to connect networks, still it's a very, very limited thing, because there is so much going on in the brain. So our desire to have a single equation or a set of equations is still not fulfilled. That is the real problem, because we do not have a supplementary area in brain which will say, okay, fine, this network task is done, switch on to the other. At the same time, the whole brain is active. What are the other parts doing when we are measuring a certain part? This is one of the pressing challenges. So today, towards the last lectures of this week 3 module, we will talk about one zone which still challenges us. If you look at your life, we all think we think, and we all love to think that we think. But do we really think? We think that whatever decisions we are taking are very, very rational decisions, and all of us are, that is one source of anxiety. Everybody wants to think logically and rationally and take rational decisions. But if everybody is doing rational decisions, if the governments and the people in their individual life, within families, students, everybody is thinking rationally, then why is so much disturbance? Have you ever noticed? We will do a small exercise. If you just look at it, I have given you 6 words here, and these 6 words, they are not necessarily divided into 2 lines. Just try to make 3 pairs out of it. Just connect. Now somebody may say danger attracts, but for most people danger will mean escape or flight, or fight or flight. Loss, eventually all losses you accept. Now exploration and attraction may go together. If you are attracted towards something, you will explore. This is a logical, rational brain which is telling you. But look at it. All rationality what is happening inside your rational thought process of matching these words? All rationality actually boils down to this basic emotions. If there is a danger, there is a fear. If there is a loss, there is grief. And if you explore, there is joy. So, underlying your seemingly normal emotions, the rational thinking are essentially these emotions. Emotion is such a huge hidden world that it never comes to our notice. Even Darwin mentioned in 1872 that autonomic responses, you remember we talked about the sympathetic and parasympathetic systems, which control your heart rate, your salivation, your pupillary dilatation, your skin resistance, your all that is controlled by sympathetic and parasympathetic system, but they are actually the intrinsic part of the emotional system. Now, what happened in psychology, as and if you can see, Darwin said that the peripheral scalemotor and autonomic aspect of emotions, they serve important function in communication and in preparation for behavioral responses. So, behavioral responses we talked about is fight or flight, which is a universal thing. So, either in the face of stress you fight it out or you escape. This is a famous man, William James. Just read this. What kind of emotions of fear would be left if the feeling neither of quickened heartbeats nor of shallow breathing, neither of trembling lips nor of weakened limbs, neither of goose flesh nor of visceral stirring were present? It is quite impossible for me to think. So, what James was saying, that if you do not have body symptoms of emotion, that your heartbeat does not go fast, when you are anxious your tummy does not go butterflies, then what is the emotion? William James was one of the pioneers of psychology. Now, William James, if you, this is around 1900, once he brought out this theory, emotions were almost pushed away from psychology, because soon after that Freud came in, and Freud said that all emotions are part of unconscious suppression and repression and all those defense mechanism. Then Freud went out. By the time behaviorism came in, they said everything, there is no thought or emotion or anything, everything is a learned pattern. Skinner and Pavlov and Thorndike. And the last to come was cognitive theory, the cognition, that everything is thought, rational thought, and you can already train your mind. So, emotions were slightly pushed off, but they have really bounced back in last 20 years, especially with the neurosciences research. And in fact, when we discuss, we often think whether Freud was right, because we'll talk, when we talk of consciousness, we will be talking about this whole concept of unconscious and conscious. So, essentially there are two theories. I had mentioned it briefly. There is one thing called Cannon-Barth theory. There is a stimulus, there is a snake here, your eyes see it. Cannon-Barth theory says that you first experience fear. It is the fear first in your mind, and then you experience all these responses in your body, trembling or goose flesh or heartbeat going fast. Whereas, the James Lange theory says that you perceive it, first the bodily experience happens and then the emotional experience. So, irrespective of what theory is correct, because theories often they try to explain and they are not the ultimate answers, you have a mental sense of emotion and you have a bodily sense. Imagine, for example, anxiety. Just before going for exam or going to ask a kid, before going for exam, you may have a fear that you may be able to answer or not answer, and have some apprehension in your head. That is one part of it. But for some people, palpitation may start or their mouth may get dry. So, that is a physical manifestation, whereas there is a mental psychic manifestation of anxiety. So, what are rewards? If you remember, I talked to you about dopamine and the reward and punishment system. So, what is the emotional experience? You may be thinking anything and thinking that okay, fine, rationally I am going to drive from this place to that place, and everything worked out wonderfully in your mind, and suddenly something happens, somebody comes and bumps into your car. The first reaction would be emotion. All rationality and thought would be will be off somewhere. So, that is the power of emotion, but emotional experience, if you look at it, so this is one feeling emotion, that suddenly you got angry, or your heartbeat may, or you may get fearful after a bump, which happen. I mean, you see all neuroscience related to life. You talk about road rage is not a well thought of thing. People start fighting, and you often witness it on the news channels, or you witness it in the paper. This is just a sudden emotional surge which comes. But after you have done an act, either impulsively, what is the emotional experience? That is the ability to reflect upon our emotions. And you have to decide whether this, if an act or an emotion makes you feel good, the chances are you will repeat it. But if you have gone on a bad trip, that will be not so good, and you will probably, the motivation to repeat or do will be less. Your motivation often comes from your emotions. So, the part of the brain which actually does it is limbic system. I haven't talked about limbic system, I just mentioned it briefly in the last lecture called Pepet's circuit, and I had left it for this lecture. It is comprised of number of cortical and subcortical areas. Cortical is, we remember the cortex, by now you are familiar with that, and subcortical. So, this is the anatomy of limbic system. The Pepet's circuit, which if you remember, I briefly mentioned, is part of the cortex dedicated to processing emotion. It comprises a ring of primitive cortex. Remember, I mentioned that it was the motor cortex which first developed in evolution, and then the emotional cortex. This is the emotional cortex which is present in mammals and a lot of other animals, in primates. So, frontal lobe, you know it very well. So, see the cingulate gyrus, which is around corpus callosum. Corpus callosum is the band of fibers which unites two cerebral hemispheres in the center of the brain. Around this is cingulate gyrus, temporal lobe, where memory and sound and speech, amygdala. So, these are the actually big structure. There is a ring in the deep brain inside. It goes like, if you take it, the brain is this way, it is like this. So, central, if you take two hemisphere, in the center there is a ring like this on both sides, and these are the structure. Thalamus is a very, very important structure. But thalamus, if you remember, is the relay center. Nothing goes to the cortex, nothing comes from the cortex, and thalamocortical connections keep you conscious and integrates information. Amygdala you would have heard of in the popular press also. This is the structure which has been most often implicated in fear and in rage and anger. Hippocampus is a structure which is involved in memory. So, memory and emotion do not go separate, because if you do not have a memory of something, you will not bother. That is why small kids are not afraid of fire or dogs, or because they have no memory. They will just, so once they go and a dog bites, that memory will. So, memory does not have only a verbal component. Memory also has a component of emotion. So, when your memories get activated, when you see something and you recall your memory, and your memory compares the present stimulus with the past one, it is actually not only evaluating on the facial features or bodily, or it is comparing that on the emotional content. So, often you will wonder that why am I remembering all these things? You are remembering because your emotional brain is remembering all that, and hippocampus, where all the short term memory, if you remember last time we talked about it, the long term potentiation, hippocampus happens to be there. So, this is just a simpler representation. If you remember last time I was telling you that whether the cortex is involved in emotion or not. For a long time we thought it is not involved, it is the thinking part of the brain, but all injuries to cortex bring lot of emotional changes. So, the prefrontal cortex, which is actually the center in the brain on the left side, dorsolateral and ventromedial, which controls abstraction, judgment, your differentiation between stimuli, taking a decision finally, is a part of not exactly limbic system, but part of the emotional brain. The association cortex, the primary cortex of movement, primary cortex of sensation, and the association cortex. Your mind, you have a mind because everything gets associated in those. So, these association areas are between cortex, the frontal lobe, the temporal lobe, the parietal lobe. Cingulate gyrus, as I said, is forms a ring. Thalamus, we all know this. Hypothalamus. Hypothalamus is a small body deep inside the brain which controls sleep, sex, hunger, thirst. All your body chemistry is regulated, and hypothalamus sends actually the chemicals to control the neurotransmitters, and the neurotransmitters control the hormones, and hormones control rest of the body. So, hypothalamus is such a beautifully connected chemical system. So, the nerves control movement and sensation, but hypothalamus through chemical messenger actually controls the secretion of controlling hormones, which controlling hormones again come through the blood to the end organs like thyroid, like adrenal, like pancreas. The secretion of the chemicals from there finally controls the rest of the body metabolism. So, some intelligent people know that man is a slave of hypothalamus, because if hypothalamus shouts thirst, you have to give it water, or if it shouts sleeps. So, the part of hypothalamus controls the circadian rhythm. So, when we talk of sleep, we will talk about it. Hippocampus, memory, and amygdala is the most important structure for fear and rage. And so, you may be wondering, what is the big deal about it? When we know so much about the network, we know about the areas of the brain, and we know this, that these parts are controlling, why can't we fit in together? I will come to towards the end, why can't we fit in together? What triggers the hypothalamus? Emotionally significant stimuli. There may be 10 things in your environment, but not all of them will be important for you. You will only react or pay attention to what is emotionally significant. So, you may have your father standing there and you may have a stranger. The chances are first thing you will pay attention is to your father. So, as I said, amygdala is the key coordinator. And the development of amygdala, if you look at it, it is here. At somehow over years, amygdala does not work in isolation, but probably amygdala is the place which actually triggers the response of fear and rage. Now, there is something called Kluver-Bucy syndrome. I mentioned it briefly. If you remove the amygdala and hippocampus of both sides in monkeys, monkeys become tame or fearless, non-emotional, blunted emotions. You do not express, and we find this blunted emotion in some of the illnesses, like where in schizophrenia, where we have a lot of negative symptoms. They will have an increased oral activity, will put everything to the mouth, including placing inedible objects in their mouth, and the sexual behavior increases, like mounting inappropriate objects. So, lot of stuff was gone in this. Hippocampus was gone, temporal lobe was, anterior tips of temporal lobe were gone. So, this was the memory stuff, and amygdala, which increases the fear response. So, this is called a Kluver-Bucy syndrome. It is very rare. And then they went on to make precise lesions, make a lesion in temporal lobe, then make a lesion in hippocampus. So, that indicated that it was the amygdala is actually the key coordinator, like thalamus is a key coordinator for integrating information, the sensory and motor. The emotion center, the emotion coordination is with amygdala, and it has been linked to emotional processing. If you stimulate it without any external stimuli, just a sort of maybe electro stimulation or a chemical stimulation, the feeling of fear and apprehension automatically comes in. And you read this is lesions of amygdala in a rare disease like Urbach-White, they are calcium deposits. They impair patient. The patient after that cannot find out emotions in the facial expressions. Already if you remember this organ which we talked about, insula, where mirror neurons are, they actually look at facial expressions and but automatically it does not reach insula. Insula does not have a separate eye to look at it. It is the same information. Now you look at the complexity of the whole thing. I am sure you will be able to understand what I am saying. You same stimulus from eye comes in a discrete feature extraction. It goes to it reaches the mirror neuron. The mirror neuron also feels the same thing like what you have, but mirror neurons will not feel anything unless the discerning emotions happen in amygdala and the Papez circuit, because Papez circuit will compare the same expression with the previous memory, and that will be conveyed to the higher centers. Imaging has revealed, this is what I was saying. So, it is the amygdala actually which responds to the different facial expressions first, and then once the emotional thing has filtered, then mirror neurons can feel it at a higher center that okay, this person is sad. Because what does sad mean? Sad is a meaning given to a certain emotional state. What is happiness? Happiness is a meaning given by the higher cortex to a certain type of set of the physical and mental state. That basic processing, the basic set of information is there with the limbic system. The meaning may be given by the higher center later on. This is a process with the same set of information. Okay. Fear conditioning, you remember we talked about the Pavlovian experiment where condition stimuli. So, all this conditioning and of fear or any other symptom for that matter is there in all animals, number one. And lot of animal experiments have been gone. This is a very common psychological thing which we find. So, this is a type of fear conditioning you do which is very unethical these days, nobody will listen. But there is something called skin conductance. Skin conductance or galvanic skin response is a psychophysiological measure. You already have some current or resistance in this. In normal, and this varies because there is a lot of blood flow which happens, and as the blood flow happens in different physiological condition, in fear and anxiety, this is the basis of what you call, this is one of the parameters of lie detector machines. The other parameters like heart rate, like pupillary dilatation, all of this put together, they assume that if you are not speaking a lie, your emotional arousability will be less if you are speaking the truth. But once if you are speaking a lie and your mind knows deeper that there is something else is truth, there will be a conflict situation in the brain. So, brain keeps passing through this bifurcations of decision all the time, in all moments. These are the big questions which we will talk when we start the 4th week lecture. This whole diversion, bifurcation and the conflicts, that raises your emotional arousability, because in the situation of conflict your mind is not clear what is happening and it does not want ambiguity. So, it does not know which way it is going to head. That changes the galvanic skin response, pupillary dilatation. You may not realize it because these are all under deep control of parasympathetic and sympathetic. The parasympathetic uses acetylcholine and sympathetic uses norepinephrine. So, now you can ask me whether, so what is so mysterious about emotions? Like we have defined network and we have given a task based imaging. So, we do task based emotional measurement also. So, this is the type of stuff which they do for fear conditioning. These are the graphs which you can see. Now, why is amygdala so important? Like hypothalamus is very important, like a small peanut. Amygdala, now you go back to what we were talking about networks. What is the point of network developing through Hebbian route or non-Hebbian route, firing together, presynaptic, postsynaptic to form connections? It is all about connection. Amygdala is sitting at a place where it has connection with the thalamus. So, there are direct thalamo-amygdala. Now, once you have a connection with thalamus, thalamus is already a point of relay of information. So, suppose for example, you get a auditory danger signal, auditory thalamus, it goes to auditory cortex and temporal lobe is the auditory cortex. Amygdala is a part of that Pepet circuit with it. So, it is very easy to make amygdala as a separate coordination center for emotion. So, maybe it is like this, if we try to look at it, the thalamus is the integration center for all the sensory and motor and the level of conscious, the oscillations which bind and all that. If amygdala had been mixed with thalamus, everything would have really got jumbled up. So, it is just at some distance separated. So, simultaneously two things are happening. One, a evaluation of the sensory thing on physical properties and a evaluation of the stimulus on emotional properties. These two things together decide a relevant hierarchy on the basis of which the higher conscious brain can decide whether you want to act on it or ignore it. And that is why amygdala actually, see now it will become clear to you. So, this is amygdala. See the type of connections, hypothalamus, sympathetic, there is a norepinephrine, tachycardia, faster heartbeat, pupillary dilatation, blood pressure goes up, galvanic skin response. Parasympathetic, through vagus there is a nerve this which comes here, ulcers, urination, defecation. VTA, ventral tegmental area is very, very important. Activation of dopamine, behavioral and EEG arousal, increase startle. So, with a small thing, with a small economy, with connections all over, this whole body thing is managed. This is important. I said hippocampus is involved in the memory thing. Amygdala may also modulate emotional memory stored elsewhere. Now, how does it do it and why should it do it? Because if what mechanisms, if these arousing events, they activate the sympathetic nervous system and hypothalamus pituitary axis, which is controls the hormone, which results in the release of epinephrine. So, this fight or flight has to be managed. Now, for an absolutely new emotion or new thing which does not have a memory, what is amygdala going to compare and what is the mind going to compare? So, mind has to compare any stimulus on its perceived threat thing in the past, and based on that emotional memory the mind will decide what to do and how are you going to act on it. So, amygdala is the hero of the emotional world. We have also seen that once you give lesion, if you destroy a bit of amygdala, this memory enhancing functions are gone, whether it is a physical injury or it is a chemical injury. So, we will talk about this in the next lecture, which will be the last lecture of third week, and we will talk more about emotion. Thank you.